Hey everyone, I'm John Lynn, the founder and chief editor at Healthcare IT Today. We're excited to bring you another in our series of interviews with top leaders in health IT. And our guest today is Jay Meier. He's Chief Identity Technology Strategist at FaceTec. Welcome, Jay.
Thanks a lot, John. I'm grateful for the opportunity to share some thoughts.
Yeah, it's great to be talking with you here at the Direct Trust Conference. A lot of interesting discussion about identity management, a number of other topics, security, privacy. But before we dive into kind of your solution and how you're helping healthcare organizations, tell us a little bit about yourself and FaceTec.
Well, as you mentioned, I'm the Chief Identity Technology Strategist at FaceTec. I've spent a lot of time as a research analyst on getting to understand the industry, all of the nuances of it, the economics of it, et cetera, et cetera. And so I do some strategic advising to the company, as well as most of the evangelizing. FaceTec is the world leading provider of, I'm going to say liveness, but we typically say three-dimensional liveness and biometric face matching. We are on track to do 3.5 billion liveness sessions in the next 12 months. And
Wow.
Our device SDK has been downloaded about 2 billion times, and it's downloaded something like 3.5 million times a day. So we are a juggernaut in the industry. We are a leader and really a thought leader, which has given us the opportunity to take the pole position out there.
Yeah, that's really amazing. I mean, the volume that you're doing, it's funny. 20 years ago, I bumped into facial recognition, fell in love, but I couldn't convince other people to do it. And now I think iPhones and Android have kind of habituated us to face matching. But
Well, they made it cool.
Yeah, exactly. And easy to do, right? The cameras have come a long way. But talk to us about what is 3D face matching. You talk about, liveness. I think that's interesting too. And how does it work?
Well, the thing about face matching is that the camera, and you know this because you work with cameras are a two-dimensional sensor.
Yep.
And two-dimensional sensors are inherently flawed in a way because they struggle to interpret three-dimensional information. But our faces are three-dimensional, right? And so as you move the camera closer or further away from somebody's face, things occur that are called perspective distortions, which is the camera just trying to figure out where to put the 3D data. The reason we are pursuing and have really invented a new form of three-dimensional face matching technology is because if you're working in 3D, you don't have to deal with those perspective distortions. And what that means is our technology is immune to the error rates that occur because of the perspective distortions. So I know this is geeking out, but our technology is orders of magnitude more accurate than the competition because they're using 2D while we are working in 3D. You mentioned liveness and matching. Those are the two critical components, right? We're hearing about deepfakes, we're hearing about spoofs, we're hearing about things that people are using to try and attack a system. And liveness is sort of the genre that we use to describe technologies that determine if you're a human being or not, right? So, and again, three-dimensionality plays a huge role in liveness determination because a human face cannot be alive if it's in 2 dimensions, right? So
Yeah.
we have some serious advantages in 3D.
That's amazing. And it is interesting to think about the whole 3D idea rather than the 2D idea and kind of, is the person really alive or is this an image of the person? But talk to us about what are some of the example use cases for this technology that you're looking at in healthcare?
Well, that's a good question. The use cases in healthcare are effectively the same use cases in any other industry. What we are doing is, in a way, protecting privileges that people are authorized to use. The vast majority of frauds, online scams, hacks, cybersecurity incidents, identity theft related things, comes from the transfer of a valid credential to someone who's not authorized to use it. And what a credential does is it binds a human being to an identity and then to privileges that they enjoy, right? So if the credential can be transferred to someone that's not authorized to use it, it means that the privilege is transferred to that person as well. And that's how they break in, right? They say that criminals log in, they don't hack in, right? Yeah. And so in the healthcare community, access control is really the way you think about it. Does this doctor have the authority to access this part of the network? Does this nurse have the authority to transmit that prescription to the pharmacy? Is this patient actually who they say they are, right? In a fraud mechanism, we know that fraud is rampant in the U.S. healthcare system. Just a couple weeks ago, the Justice Department announced that they busted a $14 billion fraud ring. Amazing. And it was all about Medicare and Medicaid, right? The nature of those frauds is the credential that represents the privilege of accessing those services, like a Medicare card or something like that, is transferred to someone else. And that person is then accessing your Medicare entitlements, right? So if we can better determine, more confidently determine that you are who you say you are, and more importantly, you're the person that actually applied for the privilege to consume Medicare or Medicaid or whatever services, then we can reduce that fraud, and we also could reduce a pile of errors that happen in the system.
Yeah, that's a good point about the errors. We just heard of some sessions about prescription fraud, where it's, a bad actor imitated the doctor, files hundreds, thousands of prescriptions, but then the person picking it up also is not the actual person. Right. They said they go and they pick some, person off the street, pay them $100, have them walk in and do it. And,
absolutely right.
And they'll pick up the drug. It's so fascinating, right? Like your solution, if they were looking at the live person, the live patient, the live doctor, none of that could happen.
Well, of course, if you're in person, you don't need to worry about liveness, right? I can tell that you're a living human being, but online, on the internet, in a network, you can't necessarily know that the thing on the other end of the transaction is a living human being, right? So deepfake attacks, AI is a great tool to make fake people, right? And so those fake people often can do things like ask for a prescription or go fill a prescription, etc. So in the electronic prescription of controlled substances, EPCS, which is a series of regulations that have been around forever, doctors, for example, are required to do advanced user authentication, presumably to determine if they are who they say they are and authorized to use the privilege of sending in a prescription to a pharmacy.
Yep.
Those technologies don't work very well for a lot of different reasons. And so we've developed a new capability that we call UR codes, which promises to eliminate a lot of those vulnerabilities and create massive efficiencies in these systems.
That's amazing. So, we're here at the Direct Trust Conference. Talk about why FaceTec chose to be involved with Direct Trust.
Well, Direct Trust is a pretty incredible organization, actually. If you think about healthcare, and let's just use U.S. healthcare as the proxy for all healthcare, there is so much data and information floating around these systems that you can't even comprehend it, right? I like to talk about identity data of administration, doctors, nurses, whoever, patient data, right? I mean, there's 330 million people in the United States, and they all have a health record somewhere, or maybe they have health records at lots of places, and those places don't know about those other health records, right? So the transmission and transfer of that information is critically important, and so electronic health records that could be transferred from my hospital in Wisconsin to a hospital that I'm using in Texas is critically important because they will have an idea of what drugs I'm on. They'll know my history. They'll be able to conduct higher, more efficient healthcare services for me and are less likely kill me by doing something bad. Right?
Yeah. Well, and there's also the issue of making sure that they match, which if you use the 3D face matching, you're matching the right patient.
Well, that's exactly the point, right?
Yeah.
So is this person who we think they are? Is this person who they say they are, right? Do we even know? So the U.S. healthcare system, you think about identity data, health information, payment information, insurance companies, Medicare, Medicaid, VA benefits are all about government systems, right? There is so many data flows of different types of related data that all converge in U.S. healthcare. And that's why the fraud is so rampant, okay? Because that's where the gold is. And so that means that's where the opportunities are. And we think with our 3D matching and liveness and our new UR code capability, we could eliminate as much as 85% of those problems in the U.S. healthcare system, which ultimately is an economic event for the country, if you think about it.
Yeah, that's a big one. So, you talked about 2D versus 3D. We hear about people trying to spoof a person's image with a picture of them or things like that. Can 3D face matching be spoofed that way with an image? Or, AI is developing all sorts of, can it be spoofed that way, using an image?
This is a great subject. It's a relatively nascent subject. AI is relatively new, and people are still figuring out how to use it for nefarious purposes and also for good purposes, right?
Sure.
AI is used by criminals to spoof these systems. AI is also used by companies to promote better outcomes for their technologies. We use AI in the development of our matching algorithms. So, the thing about a human face is it has to be three-dimensional. If a human face is not 3D, it's not a human face. So if you can determine if what is presented before the camera is two-dimensional, then it's not a human face, right? It could be a mask, though. So a mask, these are called presentation attacks. There are other things that we do in our system, measuring involuntary human cues, like the dilation of your pupils or, sweat glands and things like that, that can help us determine that this is a mask as opposed to an actual human face. So never say never. I won't say that we cannot be spoofed. But it is very, very difficult to spoof our technology, and I'll give you an example. We are the only biometric vendor in the history of biometrics to stand up our own Spoof Bounty Program. Okay, security companies do this all the time. They say, hey, evil geniuses, super geeks, try and break our system. And the whole point is that they get to understand what that attacker did, and they pay a bounty for that, right?
Yeah.
So we do that at FaceTec. We're the only vendor in the history of the industry that has its own Spoof Bounty Program, and you can visit that at www.spoofbounty.com.
Awesome.
If you can break our system, we'll pay you up to $600,000. But since 2019, we've had 150,000 attacks on Spoof Bounty. And we've only paid out twice, and those were very small payments in the first 6 months of Spoof Bounty. It was the best research and development money we could use. We knew we could see what they did, so we fixed it, and we haven't had any spoofs since.
Incredible. I like that approach. Talk to me more about what else you've done to make it secure. I think it's interesting. As I was researching FaceTec, you embed the timestamp, which that was fascinating. But anyway, talk more about what else you're doing to make sure that it is secure and reliable.
Well, we talk about a lot of those different things, and it's worth noting that the National Institute of Standards and Technology just released special publication 800-63, iteration 4 a few days ago, right? After 4 years of revisiting that document, that special publication, that set of guidelines has included, the new version of it includes a lot of recommendations and guidelines about how to actually secure an entire system, not just the data that's flowing around the system, right? So one example is that we have been harping on for a long time is if you're using a smart device or anything with a camera in it, you can spoof a system by eliminating the camera and then injecting your own false information into the feed.
Okay.
Right? So those are called injection attacks. It's a very new attack, but it is extraordinarily dangerous because it can scale so much. It's basically a computer infiltrating another computer with AI, right? So the one thing you have to do is take control of the device and the camera that is capturing the information, so that you know exactly what information you can expect from that camera, right? If we can control the camera, it makes it harder for people just to inject.
Sure.
But if we know exactly what information to expect from that camera, and in fact we can alter that information so the attacker doesn't know what should be in it.
Sure.
When we determine that there's information, there's data in that packet that doesn't belong there, we know it's an attack and we can get rid of it. Okay.
Interesting.
We were a leader in that. We've been talking about that for 5 years, and NIST just kind of came around to that one. But
Nice.
you know, there are other things. One of the advantages we have is that we've been able to determine to capture three-dimensional data about your face using a two-dimensional sensor. Well, the idea that means that we can capture matching data. Does my face match your face? At the same time that we capture liveness data. Is this face actually a living human being, right? The fact that we capture those together, and I like to say wound together like this, means that once we consume the liveness information, if we determine this is a living human being, we can delete the liveness data, which only leaves matching data. So if somebody tries to submit, if someone steals the biometric data from the database, it's only matching data. And the system is looking for the combination of liveness and matching data.
I love that.
Since they don't have the liveness data with the timestamp you mentioned, our system would reject it. It's like speaking Japanese to a person that only speaks English.
Yeah.
Right?
That's super interesting. I mean, what a great way to do privacy too, right? Because I think a lot of people worry with face matching. Are they storing my face? What does that mean? But it
Right.
sounds like that's not an issue.
There's a lot of bad information out there. You know, the civil liberties people and the ultra conservatives worry about, you know, Big Brother and what happens if you lose your face, you know, identity. It's like, your face is everywhere on the internet. If I want your face, I'll go find it on Facebook or something, right? But if you change the data file that you store in the database to something that the system will not accept, it eliminates the possibility of what's called a honeypot risk, meaning that the hacker can dig into that database and steal all that biometric data. Well, if they can't use it for anything, they're not going to steal it, right?
Yeah, they want valuable credentials or useful stuff.
That's exactly right.
That's interesting. Talk to us about how a healthcare IT company could integrate FaceTec into their product. It sounds like you have a SDK that they can integrate. Talk about that process.
You know, that's an interesting point. Most companies that try to do something like what we do are service providers, right? They have a bunch of technology and you pay them fees to do verification or matching or something like that. And it typically happens outside of your control.
Yeah.
So
upload your driver's license.
right,
do that.
into a cloud somewhere, right? You don't know where that information went. You don't know how it's being secured, right? It's a big problem, okay? So we decided, and our CEO really, who's the genius behind this, he decided that we need to move the biometric data behind someone's firewall like the hospital's firewall, right? And so what that means is that we do not do cloud services. We never see any biometric data. We never see any customer data. We are an OEM provider of software to other organizations who embed our capabilities in their stuff, in their app, in their stack, right? So it really eliminates the opportunity to lose control of that data. And in a regulatory environment in this country, imagine if you were shipping that PII and biometric data to another country to have it analyzed in some cloud, right?
Yeah.
Big no. It's a big problem. So when somebody wants to use our technology, they can go to dev.facetec.com, and it's kind of a self-serve deal. You can figure it out and test it and monkey with it and deploy it. And then when you're ready to use it, after you've built it into your app and your server, then you just sign a contract with us and we'll give you the keys to start using it. So they install a device SDK into their app. It's only 4 meg. It's not a very big file.
Yep.
And that interacts with the server SDK, which they would install on their servers behind their firewall.
Okay.
And the two technologies talk to each other and share information between each other. So it's really very simple, okay?
Yeah.
It's not as simple as just paying somebody to do it for you, but those systems are problematic for all the reasons we just talked
Yeah.
about.
Well, and every developer can do that kind of integration with an SDK.
Right.
It's not a big deal. Interesting. So as you kind of like look forward into the future, what should people understand about the future of identity management and 3D face matching and that the role of 3D face matching and identity management?
Well, I like to talk, so I'm an economist, Wall Street kind of guy, I think in terms of top down, right? And so let's just talk a little bit about the problem out there. Everybody knows that fraud and hacking and identity theft and whatever are massive problems. People don't even comprehend how big it is. We're talking about trillions of dollars of fraud every single year globally, right? The attack vector that is most common in these types of attacks is the transfer of a valid credential to someone that's not authorized to use it, right? So if you had a credential that allowed you to access healthcare services, if I could control your credential, then I could have access to your healthcare services or your bank account or your crypto account or whatever.
And
right?
that's way easier than hacking the system.
Well, hacking the system really isn't the problem anymore.
Nope.
There's a new phrase, everybody's got their slang, right? Hackers don't hack in, they log in using your login credentials. That's really what happens.
Yeah, hackers are lazy.
They're smart. They're not lazy, they're smart because this works. Guess what, folks? We've been talking about passwords need to go away. Cybersecurity is really important, but the statistics of fraud and invasive attacks like this have not slowed down one iota, despite all of the money that organizations and companies and countries have spent on these super new technologies that supposedly were going to fix the problem. Did they fix the problem? No, they did not. The problem is that the industry has looked at the attack vector the wrong way. If you think about what I just described, the transfer of a valid credential to somebody that's not authorized to use it, a credential is something that binds a physical human being binding to an identity and then to a privilege that person is allowed to use, right? So if the credential gets transferred, the privilege gets transferred. Understand?
Yeah, absolutely.
So the question is a lack of binding. We're not binding the credential to the human being effectively enough. If we were, it couldn't be transferred to somebody else, right?
Good point.
So the solution is how to bind those credentials or those privileges to a physical human being rather than to a device like your phone. Apple and Google and Samsung and all these organizations love to bind your credentials to your phone, and they even bind your biometric data to the phone, but they don't bind the phone to you. They bind it to the person that's using the phone. So if I have your phone, I have your credentials, which means that I have your privileges, okay? So what's going to happen, and this is the revolutionary aha moment for the industry, for the world really, is that if we better bind these credentials to an actual physical human being instead of some proxy device that we assume is controlled by the human being, then we can know who actually is in control of the privileges. That's what biometrics do. Okay, is they bind things to a physical human being, not just an identity. All right.
That's amazing. What a great way to describe it, Jay.
Well, and so biometrics are critically important. by extension, the best biometrics and liveness technologies are critically important. And because we are a juggernaut and leader in, is juggernaut even a good word? I don't know, but I think it's a good word. I think it's like a leader, right?
It means you're doing a lot of good work.
It means that the three dimensionality is far superior in terms of accuracy. Our architecture of our system enables a much stronger binding between a credential and an identity and a real human being, right? And the liveness is not even comparable to other liveness technologies. So biometrics are going to be everywhere. If you read the iteration 4 of 863 that just came out, biometrics for the first time are like littered through the whole thing. They were always all about cryptography, and cryptography is a great thing, but cryptography cannot determine if you're the person that's holding the device.
Yeah.
Because there's this gap between you, the physical human being, and your device in the digital realm. That's what biometrics do, is connect all of that digital stuff to an actual physical human being, so we can't transfer the device to someone else.
Amazing. Jay, this is super interesting. I mean, as a tech guy that's been nerding out on facial recognition for 20 years, it's amazing to see how far it's come and how impactful it can be for healthcare. So I appreciate you sitting down with me to talk about this and share your insights and perspectives. And thanks everyone for watching and listening.
Thank you.
If you want to find more great healthcare IT content like this, be sure to check it out at healthcareittoday.com or search for Healthcare IT Today on your favorite podcast applications. Thanks, Jay.
Have a great show.